4.1. We are gonna just review very fundamental stuff about trigonometry. First, we have angles, right? So, okay, so in maybe algebra, definitely geometry, you learned degrees is how you measure an angle, right? And then last year, we learned that there's this new thing called radian, which is another way of measuring angles. This year, we're going to learn the third way, that is called degrees, minute, seconds, or DMS. So that's the third way of figuring out an angle. So we're going to convert between degrees to radians back to degrees, and then all of them into DMS. Okay? All right, so let's start with degrees. But before that, let's kind of talk about a circle. So first thing is half of a circle is how many degrees? 180. Half of a circle is how many radians? Yes, pi. Yeah. So yes, that's why on your unit circle 180 is pi. Right? 180 degrees is pi. So 180 degrees is the same as pi. So then we can just say that they're the same. So 180 degrees is the same thing as pi. So we need to remember that that is our conversion factor. So 180 degrees is the same thing as pi. So for example, if I want to change from, let's say, 30 degrees, and I want to change from 30 degrees into radian, remember radian is the part with pi, right? So then I need to multiply by some kind of conversion factor.
Wait, you want radian?
Yeah, so I need to have something with pi in there, right? So pi radian.
So pi over 180?
Yes, so you're trying to multiply by a conversion factor. So this is how I remember. First, 180 is the same as pi. Next thing, I know that I want this eventually to look like radian, but I need to cancel out degrees. So whatever I need to cancel will always have to be in the denominator. That way it can cross cancel, right? And then the same thing as 180 degrees is pi. So I just put pi on here, and then that would be my conversion factor, and then I multiply over. The degrees are gonna cancel, and then 30 and 180 is just 6, so this means pi over 6. So 30 degrees is the same thing as pi over 6. Good? Okay. Now we're going to convert back from radian. So let's say that you have, let's do something a little bit weird, 3 pi over 2. Let's say we want to convert from 3 pi over 2 into degrees. Okay, so what would be the conversion factor?
180 on the top.
Yeah, 180 on the top and then pi on the bottom, because you know you have to cancel out that pi. So this is how I remember all my conversion factors. You need to cancel out, you need to be able to cancel out, so they have to be diagonal from each other. So then this cancels, and then 2 and 180 cancels, so that's 90. And then 90 times 3 is 270, so that's 270 degrees. Are you guys good? Easy? Okay, the next thing is degrees, minutes, seconds. This is new. So, so something like degrees, minutes, seconds, it will look something like this. Let's say it will have 7 degrees, and let's say 30 minutes. And when it says 30 minutes, the way they write minute is 1 dash, like feet. When you say 5 feet, you put one line. That actually means minute in this case. Okay, and then let's say it's also 30 seconds. The way they write seconds is 2 lines. Okay, 2 lines kind of like inches, but 2 lines means seconds. So let's say that we have 7 degrees, 30 minutes, 30 seconds. We want to convert that whole thing into just degrees. Okay, so then I need to kind of tell you the conversion factor. 1 degree is equal to 60 minutes. 1 degree is equal to 60 minutes. So you got to write that down because you don't know that as a fact. So 1 degree is 60 minutes. And then 1 minute is 60 seconds. So you already know that. 1 minute is 60 seconds. So now what we want to do is we want to convert everything into degrees. So 7 degrees stays 7 degrees. 30 minutes, we need to convert. So 30 minutes. 1 degree is how many minutes?
60.
Yeah,
Wait,
1 degree
Oh, 1 degree
is 60 minutes. So I need to multiply by what to convert it into degree? What over what? 1 over 60. Yeah, we need to be able to cancel out the minute, right?
Oh, we're trying to get degrees.
We're trying to get degrees. We're trying to get degrees. So the minute has to cancel. So 1 degree goes on the top. Yes? How many degrees is this? Huh? Half. Okay. Now convert 30 seconds. 30 seconds. We need to go all the way to degrees. But first, we have to get to minutes. How many seconds is in 1 minute? Yes, 60. So then I need to multiply by what? Remember, we need to cancel out the seconds on the denominator. Sorry. One over 60. It's not a trick question. Okay, 1 minute, 60 seconds. So then it will cancel, right? Yes? Does everyone understand what I mean by so that it will cancel?
Yeah.
Okay. Okay. Now we're not actually at degrees yet. We're only at minute. So then 1 degrees is how many minutes? 60. So I had to multiply by what?
1 degrees over 60.
Yes, 1 degree over 60 minutes. Okay. Okay, so this is 30 over 3600. 30 over 3600 degrees. Okay, convert that into decimals. I hope you guys brought your calculator today. Okay, so 30 divided by 3600. It's about 0.0083 repeating. So then what we want to do is we're going to take all the degrees and add them together. So we have 7 degrees from the original, 0.5 degrees from the 30 minutes, and then 0.0083 from the 30 seconds. So adding that all together equals 7.5083 degrees. So 7 degrees, 30 minutes, 30 seconds actually means 7.5083 degrees. Does that make sense? I converted each part into degrees and then I add it all together. I have blank looks. Yeah, okay, all right, let's try an example. So second to from the bottom, 42 degrees, 24 minutes, 36 seconds. We need to convert it all to degrees. Okay, 42 degrees, just remain 42 degrees. 24 minutes. What do I have to multiply to get it into degrees? Yeah, 1 over 60, 1 degree over 60 minutes. All right, change it into this. 0.4?
Yeah.
Okay, 36 seconds. What's a fast way to get from seconds all the way to degrees without going through minutes and then degrees?
1 over 3600.
Yeah, 1 degrees over 3600. If you're not sure why that is, go back to the original example. You see up here, my conversion factor was this. What I did was this minute's going to cancel. So then it's just going to be 3,600 and then 1. So 1 degrees over 3,600 seconds. So it's a fast way of converting, so you don't have to do it twice. Okay. This is going to equal what? 42.5?
Wait.
0.01.
Oh.
And then we add up all the degrees together. 42.41 degrees. Yes? Easy? Okay. Let's have you guys try this next one and let me know when you're done. This is 78.2564 degrees. So up around there. Okay, next, we're going to change backwards. We're going to change from degrees into DMS. So degrees into DMS is pretty simple. What happens is the first part is degrees. So you're going to take the whole number part of the degrees, and then it just remains the same. The leftover part, we're going to change it into minute and seconds. So the leftover part is 0.425 degrees. So we're going to first change that into minute. Okay, so what do I have to multiply in order to change from degrees into minute? Remember, the degrees have to cancel. Somebody over here. 60 over 1, yes. 60 minutes over 1 degrees. All right, figure out what that is. $25.5 minute. Okay, now we're going to just take the whole number minute part, keep it, and then the degrees part, we're going to change that into seconds. Okay, so every single step we take just the whole number part, we keep it, and then the decimal part, we're going to change it into the next unit smaller. So 0.5 minute is how many seconds? 30? Yes, but if you're not sure, what's the conversion factor? Yeah, 60 seconds over 1 minute. So this is going to give me 30 seconds. So then we take the whole thing together at the very end and we put it into DMS. 37 degrees is from the original problem. We converted 0.425 degrees and we got 25 minutes, that's whole minutes, and then the leftover is 30 seconds. Good? Okay, next one. Let's have you try this one. Let me know when you're done. So this one is 52 degrees, 17 minutes, 27.6 seconds. All right, next. Let's convert between degrees and radians, but let's see if you remember. 90 degrees is how many radians? Pi over 2. Yeah, so if you memorize the unit circle, that's one of the numbers you have to remember. How about pi over 3 in 2 degrees? 60 degrees. Okay, so if you don't remember, you can always just use the conversion factor and then move between the two. Arc length. All right, arc length just means if you have a slice of pizza, it's the length of the crust. So this is called the arc length, which we also say S. And I'm going to show you how the formula is derived so that you don't have to memorize the formula, because every year on the day of the test, people cannot remember the formula. But the formula is really, really, really simple because it's just logic. So I'm going to show you why the logic works. Hopefully, even if you don't remember the formula, you just remember the logic. Okay, so let's talk about a circle. A circle has how many degrees? 360. And let's say that you have a length radius r. What is the circumference? Formula.
Oh,
2 pi r. Okay, so let's say, for example, let's say that you have this pi or something that has a radius of 10. Then what is the circumference? 20 pi. Okay, then let's say, for example, you wanted to figure out how long this length is, just the quarter of it. Let's say that you just want to figure out how long this length is. Yeah. You just want to figure out how long that one section is and the section where the angle is 90 degrees. Okay? Then what would you do? Well, it's a very simple math of proportions, right? Your whole circumference is 20 pi. You want this 90 degrees part, right? The 90 degrees is 90 degrees out of the whole circle. The whole circle is how many degrees? 360. So you just want 90 out of 360, right? Yes? So 90 out of 360 is 1/4, right? You can also see that's 1/4 of the circle. So this is going to be 5 pi by logic, right? This whole thing is 360. This whole thing is 2 pi r. If you want that part, it's just that part over 360. You guys follow the logic? All right. So basically, it's saying this is the whole circumference multiplied by how many you want over the total. So let's kind of think about it in a different way. So the arc length, whatever you want, let's say this is the arc length, is 2 pi r times however big that angle is over 360 degrees. Yes? Are you guys with me? Yeah? Okay. So this is very logical. It's just, this much, I want this much. Now, remember that 2 pi is 360 degrees, right?
Oh, that cancels out.
Right? One circle is 360 degrees. A circle is also 2 pi. Yeah? So this part is just 1. So then this is r theta. So this is the formula. R theta is the formula, but like I said, at the end of the test, on the test day, most people don't remember the formula. Please just follow the logic. You're just asking yourself, how much of the circle do you want? Okay, so the formula is r theta. Remember, theta has to be in radian. If theta is not in radian, you have to convert. Okay, let's do an example. Find the length of an arc intercepted by a central angle of 1/2 radian in a circle of radius 5 degrees. All right, let's draw an example of what they're talking about. Central angle, you got to remember from geometry. Central angle means an angle made from the center of the circle. So they're saying that this angle is how big? Somebody. What's the angle measurement? How big is the angle according to the problem? 1/2 what? Radian. 1/2 radian. Not 1/2 pi. Okay, pi is not a unit. Radian is the unit. 1/2 radian. The radius is 5. The question is, how long is this arc? So S equals r theta. What is r? What is theta? 1/2. Do I need to convert? No, because I'm already in radians. So it's 5/2 inch because they tell you it's an inch. If you have any questions, please ask. Okay, let's practice. Find the perimeter of a 60-degree slice of a 7-inch radius pizza. Please be careful with a lot of things about this problem. First, perimeter. They're asking for perimeter, not the arc length. Not how long the crust is, the whole perimeter of this slice of pizza. Please write your answer in inches and let me know when you have the answer. So first you have a pizza like this. This is 60 degrees and you want the perimeter, so you know this is 7, this is 7. We need to figure out how long that is. So S is equal to r theta. R is 7, theta is 60 degrees, but we need theta in radians. So that means we need to multiply by pi over 180. So that is, cancels 3. So 7 pi over 3. So again, perimeter means add up all the sides. So that's going to be 7 pi over 3 plus 14. And this is all in inches. Good? Okay. Next, let's review some trig. Okay. SOHCAHTOA. SOHCAHTOA. We got to remember SOHCAHTOA. Do you remember what S means in SO? Sine. S means sine. What does OH mean? Opposite over hypotenuse. Opposite over hypotenuse. Okay. C means what? Cosine. Yes, cosine. And then AH means adjacent over hypotenuse. Good. TOA, T means tangent, and then OA means, Sherry's like quietly answering all the questions. People over here, are you, okay, opposite over adjacent, good. All right, what you need to remember is SOHCAHTOA only works on right triangles. If it's not a right triangle, please don't use SOHCAHTOA, it will not work. And the way SOHCAHTOA works is you need a reference angle or an angle. That angle has to be one of the acute angles, not the 90 degrees. And so what's happening is you're seeing the world from this angle. So then from this angle, that opposite side, we call that O for opposite. And then adjacent means next to. There are two sides that's next to. And this is the only side that's A because this side is called the hypotenuse. Hypotenuse is always the longest side or across from the 90 degrees. Okay, so let's review. Sine is opposite over hypotenuse. Cosine or ca is adjacent over hypotenuse. And then tangent or TOA is opposite over adjacent. Do you remember their reciprocal? Cosecant. Cosecant is, okay, so cosecant is 1 over what?
Oh, 1 over
sine. Yes. Oh, 1 over sine. 1 over sine. 1 over sine. So since it's 1 over sine, it's really just the reciprocal. So that means we can just flip the ratio. So it's H over O. Okay, secant is 1 over what? Cosine, yes. Okay, so again, we are just going to flip the ratio. So this is H over A. And then cotangent is
like sine over cosine or cosine over sine.
one of those, yes. But it's 1 over what?
Tangent.
Tangent. Okay, it is another ratio, but we'll talk about that later. This is A over O. Okay, so if you don't remember whether sine goes with cosecant or secant, just remember that S always goes with C. S always goes with C. Because a lot of times we want to say sine goes with secant, but it's not. It's S and C. Okay. All right, next. Our triangles. 45, 45, 90. 45, 45, 90 means that we have a isosceles. If two sides, the two legs are ones, do you remember what the hypotenuse is? Yes, rad 2. So it's the 1, 1, 2, or 1, 1, root 2. And 30, 60, 90. So the smallest one is going to be 30, middle one is 60, and then the 90 is the right angle. Obviously, from geometry, we learned that opposite of the smallest angle is the smallest side. So let's say this is 1, and then opposite of the biggest angle is the biggest side, so that's 2. Do you remember what the third side is? Rad 3, yes. So I remember this is the 1, 2, 3. So 1, 2, root 3. All right, let's try an example. Given that sine angle is equal to 5 over 6, find the other 5 trig functions. All right, so we need to do all 6. So let's list it all out. Okay, so we have all 6 trig functions. We need to find the other 5 because they told us the one for sine is 5 over 6. All right, so this is a right triangle. Sine is equal to 5 over 6. Sine is what side over what side? Opposite. Opposite over hypotenuse. And they said that it belongs to some angle, so let's just say it's this angle. It really doesn't matter. So the opposite over hypotenuse is equal to 5 over 6. That means opposite is 5. So you're going to label 5 on the opposite side. Where is the opposite side? That one. So this is 5. Hypotenuse is 6. What about this side? How do you figure out what that is? Pythagorean, yes, Pythagorean theorem. A squared plus b squared equals c squared. So x squared plus 5 squared is 6 squared. X is rad 11, yes. Please don't write it in decimals. Just leave it like that. All right, so now we can figure out the rest. Cosine is what side over what side?
A over H.
A over H, so that is? Rad 11 over 6. Tangent is TOA, so O over A, so 5 over rad 11, and we don't need to rationalize anymore. Just leave it as rad 11 in the denominator. Okay. The other 3 are very easy. They're just reciprocal functions. So all you do is you flip them. So cosecant is 6 over 5. Secant is 6 over square root 11. And cotangent is square root 11 over 5. So far, so good? Okay, last part. A right triangle with a hypotenuse of 8 includes a 37 degrees angle. Find the measure of the other 2 angles. This one would be very easy to find. And the length of the other 2 sides. Let's say this is x, this is y. How do you find x? You know this angle, you know this side, you don't know this side. According to that angle, what do those 2 sides make? What kind of trig function? Sine, cosine, or tangent? cosine. So cosine 37 is adjacent over hypotenuse. Okay, so then x is equal to 8 cosine 37. And then make sure your calculator is in degrees and not in radians. All right, that's it for today.